Lesson 12.5, Equations of Circles. All right, first thing we're going to do is talk about what is the equation of a circle. Theorem 12.16 says an equation of a circle with center h and k has a radius r is x minus h all squared plus y minus k all squared equals the radius squared. So what the x and y are is the point that's on the circle. The h and k is always the location of the center of the circle. And r, of course, is the radius, which is the distance from the center to any point on the circle. So what this basically is a distance formula. To find what the radius would be, you would take the square root of your r squared and then square root this whole side over here. And it's very similar to the distance formula. The difference in your x values, the difference in your y values all squared, add them together, take the square root. So there's not much to this, so let's apply this in our first example. Writing an equation of a circle. What is the equation of a circle in standard form with a center of 5, -2 and a radius 7? There are two things that you must have to either write the equation of a circle or to identify a circle. That is to find the center and know the radius. So let's take our equation here. Okay, so we have the radius and the center. So let's first take a look at our equation. It is x minus x minus h all squared plus the y minus k all squared is equal to our radius squared. So in this case, our center is 5, -2, radius 7. We're going to plug these numbers in. So we're going to do x minus our x coordinate, which is 5. And then we're going to take our k, which is going to be our y coordinate of our center. So y minus -2 all squared is equal to 7 squared. Now in the equation it's the radius squared, so whatever that value is should be squared. So as we go through here, we'll finish writing these as x minus 5 all squared plus, change the sign here to plus and plus, which gives us y plus 2 all squared equals 49. And this is the equation in standard form. Your center is going to be at -5, 5 and -2. It's always opposite what it is in here. If you remember when we wrote equations of lines and we put it in point slope form, we always took the opposite of what was inside the parentheses. So let's take a look at the next one. What is the equation of a circle in standard form with the center -2, -1 and a radius of the square root of 2? So pause the video, try this one, and in a couple minutes come back and see what you got. All right, let's see how you did. Take our basic equation in standard form, plug in our center, which is at -2, -1, so it's going to be x minus a -2. That changes to plus 2 all squared, y plus 1 all squared, and then when we square a radical 2, remember that when you square a square root, the radical disappears and you're left with the number underneath. So the square root of 2 squared is 2. Now if you wanted to double check that, you could do square root of 2 times the square root of 2. That gives us the square root of 4, and as we know, the square root of 4 is 2. So this is what you should have gotten. All right, let's go to the next part. Example 2, using the center and a point on a circle. So now we're still writing equations, but this time we're given something a little different. We're given a center and we're given a point on the circle. So let's take a look. We know what our equation is. It is x minus h all squared plus y minus k all squared is equal to our radius squared. Now in this case here, we do not have the radius. So if we plugged everything in here, we would have the equation of the circle, we'd have our x minus 1 all squared plus, this will be y minus negative 3 all squared is equal to our radius squared. So I'm going to go ahead and change this here. We got x minus 1 all squared. This will be y plus 3 all squared is equal to our radius squared. Now, at this point here, what we're going to do is we're going to plug in 2 for our h and k. For our x and our y. This is our x, this is our y, this is our h, this is our k. So now as we plug this in here, we're going to get 2 minus 1 all squared plus 2 plus 3 all squared is equal to our radius squared. Now, 2 minus 1 is going to give us 1 squared. This will give us 5 squared. This gives us 1, 25, and then we get 26 is equal to our radius squared. Now, at this point here, you can use the 26 as your radius squared. You could take the square root, only to realize that the radius is going to be the square root of 26, so that means that r is equal to square root of 26. But when we plug it back into our equation, it's going to be the squared value anyway, so you might as well use the r squared is equal to 26. So now as we rewrite our equation, it's going to be x minus 1. So we're going to go back to this part right here. Okay, and we're going to do this line, x minus 1 all squared plus y plus 3 all squared is equal to 26. And this is the equation in standard form of a line with the center at 1, negative 3, and it goes through point 2, 2. Alright, so now I want you guys to try part B. Okay, let's see what you did. So we started over here at x minus 4 all squared plus y minus 3 all squared equals the radius squared. So what it is, I took the center and plugged it into our equation. So what we had to do is find our radius. So to find our radius squared, we plugged in your h and k. In the equation, we got negative 1 minus 4 is negative 5 all squared is positive 25. 1 minus 3 is negative 2 all squared, which is a positive 4. Add those together, you get 29 equals our radius squared. And because our equation has the radius squared in it, we're just going to use it as equal to 29, instead of having to take the square root of 29 and then squaring that. So hopefully you got this step right. If not, rewind it, look again, and hopefully you'll get it right. Let's look at the next part. Graphing a circle. Now, when you make a call on a cell phone, the tower receives and transmits the call. A way to monitor the range of the cell tower system is to use the equation of circles. Suppose the equation is x minus 7 all squared plus y plus 2 all squared equals 64. This equation here represents the position in the transmission range of a cell tower. What is the graph that shows the range of the tower? Now, given the following graph, what we need to do first is we need to first set up our xy coordinate grid. So, in this case, because of the size of the numbers here, I'm going to have to make each box in here worth 2. So what I'm going to do is I'm going to start over here, and it looks like everything is going to be, my center is going to be over here at positive 7 and negative 2. In fact, that's the first thing you want to do is identify your center. So the center of this is going to be opposite of what is the x. So this will be, the center is going to be our positive 7, and since this is positive 2, it's going to be a negative 2. So when you're identifying the center from the equation, it's always opposite. So that's our center, and our radius is going to be the square root of this number here. So if we take the square root of 64, that gives us 8. So the answer here would be 8. Now, so we have our center and our radius. Now we can graph the circle. So I need to be able to go over 7 and negative 2, and then be able to go out 8 in every direction. So I can come over here and go, say, right here, draw my y-axis. I'll set up my x-axis here. Once again, I'm letting each point be worth 2. So this will be 2, 4, 6, 8, 10, 12, so on and so on. This will be 2, 4, 6, 8, 10. So the first thing I'm going to do is locate my center, which is going to be over 7 on the x. So that's here 6 and 7, halfway between is 7. And we're going to go down -2, which is going to be one whole place down. So that becomes my center. If you want to mark it as your center, you can. Now we need to go out 8 in every direction. Since most of you don't have a compass handy on you, what you can do is count over 8, make a point, count over 8 this way, make a point, 8 this way, make a point, and 8 down this way. Remember, we're counting by 2, so this will be 2, 4, 6, and 8. Then over here we'd go 2, 4, 6, and 8. So here in the middle, staying in the middle, we'll go up 2, 4, 6, and 8. And down here, 2, 4, 6, and 8. So I realize that not everybody's going to have a circle tool as fancy as mine here, but you can graph it like this and then kind of give it a nice little sketch. So it should look something like this. Okay, so we get all the points, and the boxes here are not exactly drawn exactly square, so it's going to be a little bit off, but it should have this general shape. All right, now pause the video, you work part B, and come back and see how you did. Remember, the first thing you need to do in every problem is always identify the center and the radius. All right, so let's first identify the center, and hopefully you did that correctly. The center in this one is going to be opposite of -2, which is a +2, opposite of -3, which is a +3, and then the last thing we need to identify is the radius. So we take the square root of 100, and that is going to be that equal to 10. So we're going to go 10 in every direction. Our center is going to be at 2, 3. So we need to set up our XY axis. This one I'm going to set a little bit further over. Make sure that everything fits. And let's see here. How about somewhere right in here? Should make everything fit on here. Oh, can't have that line slanted. Okay, so locate our center. So the center we're going to go over 2. Once again, I'll let all my points be, all my boxes be worth 2. So this will be 2. Then we're going to go up 3, which will be up about this point right here. Once again, 2, 4, 6, 8, 10, 12, 14, 16, and this will be 18. Over here going up, that'll be 2, 4, 6, 8, 10, 12, and 14. So over here we got -2, -4, -6, -8, -10. All right, so now we're going to locate our points. This is our point here. Let's pick our other points. I'll put them in green. So we can see we're going to go 10 in every direction here. So from this point at 3, we're going to go over to 12. We're going to go up 10 from here. We're at 3, so we're going to go up here to 13. Now, over at +2, we're going to go 10 over here. That's going to put us at a -8, which should be about right here. And then once again, we're going to go down here. We're at 3 up here. So it takes us 3 to get to 0, which means I need to go 7 more down here. That's going to be 2, 4, 6, and 7. Now, assuming that my graphs are square, which they're probably not, we'll draw our circle. And that was a little bit bigger, so let's not use that. Let's try this. And it should look something like that. Remember, yours, as you draw it, may end up looking more like a square with the rounded off edges. That's okay, as long as you're able to do it like this. When you're doing on your homework, there is a graphing tool that will allow you to draw it perfect. All right, writing the equation of a circle. So now we've we've written the equation given the center and radius. We've looked at graphing given this, finding the center and radius. Now we need to write the equation given the picture, given a circle. So in the first part here, we first need to do, and like all problems, we need to locate the center and identify the radius. So the center is located at 2 on the x and 0 on the y, which means that it's going to be at 2 and 0. The radius here, now you can count from any direction, go on here to see where it crosses a point here. So we're going to go from here, we're going to go 1, 2, and 3. Radius of 3. So now it's time to write the equation. You're going to have x minus our h, which is 2, plus we have y minus 0 all squared is equal to 3 squared. Now when we have this case right here, when we have a 0, when we rewrite this, when we're squaring our radius, we're just going to put y minus 0, which is just y, and we're going to square it like so, equals to our radius squared, which is going to be 9. So this becomes your answer, x minus 2 all squared plus y squared equals 9. So now you try B, come back and see how you did. Alright, so we identified our center, and you should have identified it at -1 on the x and 1 on the y. Radius, counting out either direction, 1, 2, 1, 2 this way. Now, as we plug in our points here, it's going to be x minus a -1, changes to x plus 1 all squared, y minus 1 all squared equals 2 squared, and we end up with the final equation of x plus 1 all squared plus y minus 1 all squared equals 4. Alright, let's go to our final example, example 5. We've got two parts here, writing the equation in standard form with the given diameter. So, once again, the first thing we need to do is we have to identify the center and the radius. So these points right here are the given points, are the diameter of our circle. So we have to do two things. We have to find the radius and we have to find the center. Now to find the center, we're going to we need to find the middle of this line segment, which means we're going to use the midpoint formula. So the midpoint formula, which is going to be the center, is equal to the sum of our x's, 3 plus 7, and divided by 2. That's for our x's, and our y's will be 0 plus 6 divided by 2. 3 plus 2 is 10. 10 over 2, and this gives us 6 over 2, which gives us our center being located at 5 and 3. So we have the center now. Now we need to find the radius. Well, the radius is, we're going to do this, we just have to pick a point, and we're going to find the radius like we did before. Now, easiest way to do this is pick the one that has a 0 here. If there is one. If there's not, it doesn't matter which point you pick, you're still going to get the right answer. So this will be my center, which will be my h and k. So it'll be x minus 5 all squared plus y minus 3 all squared is equal to my radius squared. Now what we're going to do is we're going to substitute in our pick one. I'm going to choose A because it's got a 3 and a 0. This becomes it's 3 minus 5 all squared plus 0 minus 3 all squared is equal to our radius squared. So we want to make sure we grab the right one. You could do this with 7 and 6 and still get the same answer, but anytime you have a 0, it makes it a lot easier to work. So this gives me -2 all squared, -3 all squared. Now square a negative number, it becomes +4. This becomes a +9, and the radius squared is equal to 13. So we'll go back to this equation at the top, and we're going to substitute 13 in for r squared, which will give us our final equation of x minus 5 all squared plus y minus 3 all squared is equal to 13. And that is our final answer. So now I want you to try part B. Given A at 0, 0, B is at 8, 6. Remember, you got to identify the center and identify your radius squared. You don't necessarily have to have your radius because you're going to square it in the end. So try this and then pause the video, come back, and we'll see how you did. Alright, so let's make sure you got it right before we show you the final answer. We start off by locating our center by doing the midpoint formula. So we add our x is 0 plus 8 divided by 2, 0 plus 6 divided by 2 for our y's gives us 8 over 2 and 6 over 2. And we simplify that to get 4 and 3. So the center is located at 4, 3. So then we come over here and we plug it into our equation. X minus 4 all squared plus y minus 3 all squared. Now we're going to plug in, and it's easiest if you pick the one with 0, so we're going to choose point A, which is going to be 0, 0. So 0 minus 4 is negative 4 squared. 0 minus negative 3 is negative 3 squared. Negative 4 squared is 16. Negative 3 squared is 9. And you add them together to get 25 equals the radius squared. So you could do the square root of this and find the radius is going to be 5. But when you go back and plug it in your final equation, you're going to have x minus 4 all squared plus y minus 3 all squared equals our radius squared, which is going to be 25. So that concludes our lesson on equations of circles. Make sure you do your homework, and you can always go back and rewatch the video to catch anything you missed.